Okay, my name is Eric Steiner. I'll be presenting on Chapter 11, which is Utilizing Experience-Based Principles to Confirm the Suitability of a Process Design. Outline what we'll be talking about is first we'll look at an introduction to what heuristics are, the main characteristics of those, how they're developed, and then a table of where you can find them in your book, and then conclusions. A heuristic is a statement that reduces the needs for calculation. So there are different heuristics for equipment sizing, for operating conditions, for equipment performance, and these are just shortcut methods, also called back of the envelope, just quick approximations that you can do in meetings or to get a quick understanding of how much something's going to cost or how big it needs to be. The four basic characteristics of these, first, they do not guarantee a solution. They are wide approximations. So there's a lot of assumptions made just to give you a base idea of what the answer is going to be. Certain heuristics can contradict other heuristics because they're developed by different experienced engineers. So everybody might not come to the same conclusion about the process that needs to be taken. They do, however, reduce the time needed to solve a problem since it's just a quick assumption, approximation as to how to get to the answer. And they can only be used in the immediate context. They're not in any way, shape, or form an absolute standard for how to get an answer. They're developed, it's called the PAR process, which stands for predict, authenticate, and reevaluate. When you predict, that's a quick assumption or approximation, trying to get a quick answer to how to solve a problem you're stuck at. Authenticate would be to do it the long way, see how you would go about doing it if you had to go the entire process, all the math, all the calculations to be done with that approach. And then you compare the two when you reevaluate to see if your prediction, your close approximation, is close enough to the actual answer. So you'd have to do this many times before you can finally say that you have a heuristic for that process because, different scenarios will change how well it works. Nothing's happening. Here is the list of heuristic tables in your book. It's in Chapter 11. There's physical properties. You have different properties with temperature, pressure. There's all sorts of things. Different equipment, you got piping, you got pumps, you got heat exchangers, distillation towers, pack towers, liquid-liquid extraction, refrigeration, all sorts of different tables. Can't use that. So here is an example. This is one of the smaller of the tables in the book. This is for drivers and power recovery equipment, and they just say, here's basic efficiencies for different motors, and so an electric motor runs at about 85 to 95% efficiency. That's just an approximation. A steam turbine's 42 to 78, and then a gas engine's 28 to 38% efficient. So if you have an operation where you need less than 100 horsepower, I say the cheapest approach is to use an electric motor. But when you go above 100 horsepower, it's just an approximation that a steam turbine is usually going to be the most cost-competitive approach. And then the combustion should only be used when you're in mobile or remote areas. So in conclusion, heuristics provide a quick solution to an otherwise extensive calculation that's just been developed by experienced engineers looking at different scenarios. It's just a good guess at how the thing's going to work. So for this project, it would be the heuristics provides a good starting point for figuring out how to size your equipment. It shows you some good assumptions that can be made, which can help overcome some hurdles that we're facing. But it is not in any way a final design solution. You need to make sure you go through and look at all the math before you can finally declare victory, I guess. So does anybody have any questions?
I have a question.
Oh.
Did you use any heuristics when you were working on your project?
I did not. I did not know they were in the book. I guess I used some heuristics in deciding some efficiencies or just kind of picked out of the air and conversions in a reactor kind of
So you
thing.
kind of developed your own heuristics?
Without knowing that's what they were, yes.
Which table would be most useful
I think that distillation tower one's going to be pretty useful. I haven't looked at it. It's pretty in depth though, so there's quite a few of them though.